3 is relaxing yet another assumption, that's incompressibility. This is another assumption, just like the fluid being inviscous, is an assumption that doesn't make sense if you just take the face value of it. We all know that air is compressible, right? If you have a pump to your bike, you know when you compress the air into your bike tire, it's getting compressed, right? I mean, the volume doesn't change at the end, and yet you are compressing more air into the tire. So air is, of course, compressible. So what does it mean by assuming that air is incompressible? Well, what it means is actually a lot more subtle than what it seems to be. We are basically assuming that the pressure, right? This is the first time we are mentioning pressure. The pressure field around an airfoil, it's such that it makes the streamlines curve the way it does. It makes the streamline, for example, attach the surface when it wants to attach the surface, right? And all of this only holds true when the pressure field can sense what's happening from far away instantaneously. And that could only be true if the speed of the flow is much, much less than the speed of sound. Because in reality, the pressure field senses what is happening in a faraway place through actually sound waves, right? Sound is actually the way information propagates through the flow field. Pressure waves, also known as sound waves. Okay, so basically incompressible essentially assumes that the speed of sound is infinitely fast. Well, compared to what? Compared to the velocity of the fluid or the velocity of the airfoil or airplane. So compressible aerodynamics starts to relax the assumption that speed of sound is infinitely fast compared to the speed of the flow or airplane. We are starting to look at flow speeds that approaches the speed of sound. Okay, where you can no longer assume sound travels very fast compared to the fluid. We're going to be looking at subsonic conditions where the Mach number, the velocity of the fluid, divided by the speed of sound. The Mach number, although it's still less than 1, it's on the order of 1, right? Like 0.8, 0.5. We are looking at transonic conditions when the Mach number is high enough that somewhere, at least the one point in the flow field, has reached supersonic conditions. That's what's called a transonic flow, right? Transonic means part of the flow is subsonic and it goes through the procedure of becoming supersonic. That's transonic. And we're also going to be looking at supersonic flow, right? Where the free stream, it's supersonic, is faster than the speed of sound, or equivalently looking at a different frame of reference, the airplane is traveling faster than speed of sound.